Okay, welcome back to our second special factoring form. These are the only two that we're going to be working with, the difference of squares and the perfect square trinomial. If you notice on your factoring rule sheet, there are two more, one called the difference of cubes and one called the sum of cubes, but we will not be working with those. We will only be working with the difference of squares, which we already saw, and now we're going to be working with a perfect square trinomial. So perfect square trinomial generically can look like x squared plus 2 times x times y plus y squared, or it can look like x squared minus 2 times x times y plus y squared. And then that's the multiplied form. It goes into the factored form of x plus y squared, the quantity squared, or it goes in x minus y, the quantity squared. If you notice, this sign and this one are always the same, and this sign is always positive. Okay? So, here's our first example. 49z squared minus 14z plus 1. So, using our factoring rule sheet, rule number 1, is there any greatest common factors? There are not. Rule number 2, is it a special factoring form? Well, remember I said we have lots of questions we have to ask about this. So, our first question, if it's a special factoring form, a pattern, either the difference of squares pattern or the perfect square trinomial pattern. The first question is it a binomial? Well, this one is not a binomial. Binomial meaning two terms. That means that it is not a difference of squares. So our next question is it a perfect square trinomial? Well, trinomial means three terms. And this one has three terms, 49z squared, 14z, and 1, three terms. So yes, this is a this is a trinomial. We do not know yet whether it's a perfect square trinomial. So the next thing we want to ask then is this sign right here, okay, this one, is that a positive? Well, yes it is. In a perfect square trinomial, this sign is always positive. So it's the second sign in our trinomial. So now we can go to doing the same kind of thing we did for the difference of squares. Let's see if we can find it Rx and Ry. So first I have to look at the first term. Can I get an even square root of that? Well, the square root of 49 is 7. The square root of z squared is z. Well, that worked. Then I have to see if I can get an even square root of our last term. Well, the even square root of 1 is 1. Now, if this had been a difference of squares, I'm done, and I just need to take these two, the 7z and the 1, and plop it into the pattern. But I'm not done yet because I still need to check my middle term. So in a perfect square trinomial, the middle term is always 2 times x times y. So in my case, 2 times my x is 7z and my y is 1. Well, when I multiply these all up, I get 14z. Is that what this middle term is? The answer is yes. And so now I can say, yep, this indeed is a perfect square trinomial. It's going to be this guy because it's got a minus sign. So then I just put it into the pattern of 7z minus, because this guy's minus, 1. That's my x. The 7z is my x. The 1 is my y. The quantity squared, and I'm done. Now let me show you how this one works. So let's check this. Now, this really means, let me get rid of this little, okay, oops. 7z. Okay, this really means take this base and multiply it by itself 2 times. So that's really 7z minus 1 times 7z minus 1. These are both the same. The signs here are the same, unlike a difference of squares where the x's are the same, the y's are the same, and the signs are different. So now when I multiply this out longhand, 7z times 7z is 49z squared. 7z times negative 1 is negative 7z. 7z times negative 1 is negative 7z. And negative 1 times negative 1 is positive 1. Now again, I've got 2 middle terms. How many terms do I have in the middle? 2. That's why we always multiply these 2 times 2. And I multiplied my x and my y. So, oh, will you guys go away? I'm learning how to use this, guys, so bear with me. Go away. Okay, so negative 7z minus 7z gives me negative 14z when I combine those like terms. And I come back to what I had to begin with. And this always happens every single time. Okay, that's why it's a pattern. And I do not want to ever see you, when it's a perfect square trinomial, multiply the 49 times the 1 and stretch your middle term, which you can do, but that's doing it the long way, and we don't want to do that anymore. So let's do another example. How about this one? 9a squared plus 48ab plus 64b squared. Okay? So, rule number 1, any greatest common factors? Well, there are not any greatest common factors. Rule number 2, is it a special factoring form? Well, maybe. We don't know yet. So, rule number 2, first question we want to ask is it a binomial? The answer is no. So the second question we want to ask is it a trinomial? Yes, it is. Third question we want to ask then, if it is a trinomial, or the first question for a trinomial, is this guy a positive? Because in a perfect square trinomial, this second sign is always positive. So, yep, this one is positive. So now we just need to see if we can make this work. So if this is a perfect square trinomial, can I get an even square root of 9a squared? Well, that would be 3a. Can I get an even square root of 64b squared? Well, that would be 8b. Then I need to check my middle term. 2 times x, my x is 3a, times y, my y is 8b. So 2 times 3 is 6, and 6 times 8 is 48, and a times b is ab, and indeed, that is what our middle term is. So this is a perfect square trinomial. So that's my x. Plus goes in here because this is plus. And then that's my y, the quantity squared, and I'm done. Okay? Let's do one more really quickly. Okay? So let's have... I have to think of one. I didn't come up with one. I'm sorry, guys. So let's say 25y squared. We'll make it another minus. I'm going to do this. So 30y plus 9. Okay. So, I hope I did that right. We'll see in a minute. Rule number 1, any greatest common factors? There is not. Rule number 2, is it a special factoring form? Well, I do not know yet. First question, is it a binomial? If it's not a binomial, it cannot be a difference of squares. Is it a trinomial? Yes, so it might be a perfect square trinomial. First question, is this second sign a positive? Well, it is. So let's go on and see if we can answer yes to the rest of these questions. What is the even square root of 25y squared? Well, that's 5y. What is the even square root of 9? Well, that's 3. Now remember, I have to check my middle term. 2 times 5y times 3, x times y. That's 10 times 3 is 30y. Is that what our middle term is? It is. So this is a perfect square trinomial. So then I put my x and y in. I need a minus because in the original it's a minus, quantity squared, and I'm done. But guys, if I answer no to any of the questions anywhere along, it doesn't mean I'm done. It just means I need to move on to rule 3 and go from there. So if this didn't work, if maybe it had been 40y in the middle, then it didn't work. I just go on to rule 3 and keep going with the stuff that I know there. Okay?